Hello, this is Sayyedjavad Ziaratnia from Shibara Institute of Technology. Today I would like to talk about our latest research about multimodal deep learning for remote stress estimation using CCT-LSTM. So first we'll go through introduction. We know that stress is linked to a variety of mental disorders, like it has a link to anxiety, depression. Also, it has a negative correlation to cognitive function, like people with high level of stress, they having poor memory and attention skill. And the situation now after the pandemic is worse than ever, and people feeling more level of stress. Stress estimation has a variety of applications. So it can be used in healthcare as early stress detection and monitoring prevent long-term health issues. And for robots, it can improve the human-robot interaction by adapting their interaction to the human's stress level. And it can be also used for car industry as it can enhance the driving safety by stress monitoring. We can prevent the negative impacts of driving with stress. So what are the common methods for stress estimation? There are maybe two methods. First is questionnaire, which is based on a couple of questions and the answer of the subject to those questions. It can be in the form of the paper or digital form, which is really easy. It can be applied really simple. But the problem is that we cannot put all the people with variety of cultures into a couple of questions. And this is almost impossible. But we have, on the other hand, we have the physiological measurement. Sensors like GSR, ECG, or PPG, along with machine learning for stress estimation. These are good. This is a very accurate method because we can get the unconscious cognitive activity of the body, but we need the professional person for installation, and it's not available because we don't have this sensor in our home, and we just have it in the clinical environment or experiment environment. So now we want to come up with a method that is accurate and widely accessible, and it's remote. It can be done by your phone, the camera of your phone, or the camera of your computer. Both for stress task classification and multi-level stress estimation. We want to know what is the task that inducing the stress, and also we want to know the level of the stress. So our proposal is multimodal deep learning for remote stress estimation, and our pipeline has two modalities: remote rPPG and facial expression. Then we would have the compact convolutional transformer, CCT, along with the LSTM block. And then finally, we would get the classification for stress task and stress level. As the background, we have the PPG and rPPG. PPG is a simple optical technique for getting the blood volume change. We have two sensors, emitter and detector. Emitter sends the light to the vessel, and then we have a reflection. By getting the contrast of these two, we can get the blood volume change. rPPG is exactly the same thing, but it's doing remotely, just with a simple RGB camera. So we have two reflection, one from the contact of the skin and one from the vessel. By getting the contrast of these two, we can get the blood volume change remotely. We are also using facial expression. For this, we are using 478 landmarks of the face using medial pipe. And then for the backbone model, we are using Compact Convolutional Transformer, which is a branch of Google Vision Transformer, but with a couple of changes. So instead of embedding the input into the patches, we are applying convolutional layers, and then instead of linear projection, we are doing deploying. And also in the tokenization, instead of slice, we are using sequence pooling. These changes actually made the model very light and very fast, but it's still capturing the same accuracy to vision transformer. So that was the reason we used it as a back model. We use this as a backbone model. And then we are also using LSTM block, long short-term memory, to capture the long-term dependencies in our time series data, both for facial expression and our PPG. And for the data set, we are using UBFC-Phys dataset, which is a dataset comprised from 56 participants. We have 3 tasks: rest, speech, and arithmetic tasks, and 2 groups. Control group has easier tasks, so they tend to have a lower level of stress. And then test group has more difficult tasks, so they supposed to have a higher level of stress. So our objective is to do stress task classification for T1, T2, and T3, and multi-level stress classification: no stress, lower stress, and higher stress. For this, we are using arithmetic tasks because we believe that this is the most difficult task across the others. And we'll be using no stress and arithmetic tasks of the control and arithmetic tasks of the test group: relax, lower stress, and higher stress. For the method, we have the video or facial video of the subject. Then we have two modalities, facial expression and remote PPG. We would do the feature extraction. Then fusion of the features of these two modalities goes to LSTM block. And then we would have the two experiments, one for stress task classification, relax, speech task, arithmetic task, T1, T2, T3, and also one for multi-level stress classification, relax, lower stress, and higher stress, T1, T3 control, and T3 test. So the pre-processing for facial expression would be 60 seconds of window size plus 50 seconds of overlap. Then we would do it for we would do the landmark detection, the extraction for all the frames, which would give us 478 landmarks for each coordinates, and then we would make this time series of landmarks for each coordinates during that window size. Then we are applying PCA for each coordinates and applying Markov transition field on it. And then we would assign each of these to each color channel, RGB, and then finally we would have this image representation. For the rPPG, we have the same thing. We have 60 seconds of window size and 50 second overlap. For rPPG extraction, then we are applying noise reduction filters to get the clean PPG signal. And then finally, we are applying Markov transition field to get the final image representation. For the feature extraction, we are using Compact Convolutional Transformer to do the feature extraction both for facial expression, 478 landmarks, and rPPG signal. But the problem is that the model by itself doesn't have the ability to for the pattern recognition, temporal pattern recognition. So we are adding long-term short memory, long short-term memory LSTM to get the temporal pattern recognition. And as you can see now, we have a block of the LSTMs here to get the time dependencies features. And then finally, we would have a CCT-LSTM as a unified pipeline. Then we would have two modalities, CCT for facial expression and remote rPPG. Then this LSTM block actually tries to analyze the temporal patterns of the extracted features. And then finally, we would do the stress classification for two tasks, one for the stress task classification and one for multi-level stress classification. So as for the result, for the first experiment, stress task classification, we have 56 participants. We divided into sevenfold, 6 subsets used for the training and 1 used for the testing. First, we trained 1 CCT model for each of this modality, facial expression or remote PPG, without having the modalities together, to find out what would be the performance of what would be the potential of this and multimodality. So for facial expression, CCT model for facial expression, we got the satisfactory accuracy for binary, same for rPPG. But when it comes to T1, T2, T3 multitask classification, the accuracy is not that much. But when we put our pipeline together, when we put a unified CCT-LSTM, a multimodal pipeline, we are getting the accuracy actually dramatically increased. So now we have a very good accuracy and satisfactory accuracy for stress task classification. Also, this is the comparison of our obtained result, our multimodal CCT-LSTM to the previous works. You can see that our model got the highest accuracy to be compared with the others. And for multi-level classification, we did the exact same thing, one CCT for each of the modalities. So you can see that we got 60% for both the modalities, remote PPG and expression. But when we combine these two together, we are getting 80% of accuracy, almost 20% of increment. So this shows that what is the potential of multimodality for the stress-related tasks. And then you can see that in our fivefolds, the highest accuracy was around 98%. And this shows somehow the data set is not generalized that much. So if we increase the number of participants in the data set and more larger data set, they might be able get to have this high accuracy over the all folds, not just one. And this table also is a comparison of the CCT for rPPG and facial expression aligned with the multimodality of these two. As a conclusion, stress estimation is crucial as it has an impact on physical and mental health, and it can be applied in various domains like healthcare, driver monitoring, and human-robot interaction. And our novel multimodal deep learnings, CCT-LSTM, outperform the other attempts, both for task classification and multi-level stress classification, which sets a new benchmark in our field. And then as a future plan, we want to do the hyperparameter tuning for the model and also the data preprocessing. And then we want to investigate number of landmarks and facial landmark methods on the precision, and also applying the rPPG method, various rPPG methods with variety of SNR signal noise ratio to find out what would be the effect of it on model efficiency. So thank you very much for your attention.